Bismillahirrahmanirrahim. Assalamu alaikum students. Today we are going to discuss another problem. So let me write the problem. The problem is like this. The problem says to keep an object moving in a circle at constant speed requires a force called the centripetal force. And the problem says do a dimensional analysis of the centripetal force. This is our problem. So let us move to the solution. We know a particle having mass m moves in a circle having radius r at constant speed v, then as you know, it requires a force called centripetal force. Why we call it centripetal force? Because this force is pointing always towards the center of the circle. So if a particle having mass m is moving with speed v, which is constant in a circle of radius r, it requires a force. So you can see the mechanical variables on which centripetal force, so we represent F by, we represent centripetal force by F, so let F be centripetal force. M is mass of the moving object, mass of the object, V be speed of the object, and R radius of the circle in which the body or object is moving. So the mechanical variables on which this force F could depend are mass of the object, speed of the object, and radius of the circle. So we can write, therefore, F proportional to m raised power a, v raised power b, and r raised power c. While you know this symbol means is proportional to right? And A, B, C are numerical exponents to be determined numerical exponents to be determined from analyzing the dimensions, right? So let us move. We know the force has units of kg times meter per second square, and therefore its dimensions are mlt minus 2. mlt minus 2. Therefore, we can write using these dimensions in this equation. Let me use another color. I can write m l t minus 2 is equal to dimensions of mass is m raised power a. Then I have L by T raised power B and L raised power C, right? Because I can write first F is equal to M raised power A, V raised power B, and R raised power C. Then we substitute the dimensions. Dimensions of force are m l t minus 2. Dimensions of mass is m raised power 1, so it is m raised power a. For speed, it is L by T, so it is L by T raised power B. And for distance, radius, it is L, so it is L raised power C. So when we make adjustment, so we will get m raised power A, L raised power B plus C. We combine these two L's, L raised power B and L raised power C, and we have T raised power minus B. We have MLT minus 2 is equal to M raised power A, L raised power B plus C, and T raised power minus B. You know the idea of dimensional consistency. What does that mean? Dimensional consistency means that the fundamental dimensions must be the same on each side. So that is possible when the exponents on both sides are equal. Exponent of m on left side is same as exponent of m on right side. Same goes for L and T. So we equate them. Thus, equating the exponents A is 1, B is 2, B plus C is 1, because these are exponents of m, exponents of L, and exponents of T, right? So when we equate exponents of m, as you can see from the equation, here it is 1, here it is A, so A is 1. When we equate exponents of L, we get B is equal to exponents of T, sorry, it's exponents of T. This is here. Let me use another color. This is here exponent of T. And this is here exponent of L. Now see, for M, A is 1, A is 1. For L, B plus C is 1, B plus C is 1 for L, and for T, then C minus B is minus 2, that is B is 2, right? So we are equating the coefficient, these exponents. For M, B is 1, for T, B is 2, and for L, B plus C is 1. So it means C is minus 1. The C will be 1 minus B. B is 2, right? The C will be 1 minus B, and from this, when you put B equal to 2, you will get C as minus 1, right? So here the values: A is 1, B is 2, C is 1 minus B, which is 1 minus 2, which is minus 1. So we have all the three values. Therefore, the resulting expression is the resulting expression is, we substitute the values. F is proportional to, let me write proportional to M V square by R. How? Because C, A is 1 and A is the power of M. So it is F is proportional to M raised by 1. B is the power of V, B is 2. There is V square. And C is the power of R, which is minus 1. So it comes in the denominator. So we have F is proportional to mv square by R. The actual expression which we derive from Newton's laws and the geometry of circular motion is F is equal to mv square by R. As you know, and you also know, here the constant, dimensional analysis can't tell us anything about constants that do not have dimensions. Let me write it. Dimensional analysis can't tell us anything about constants that do not have dimensions, right? Need to remember this. In this case, that constant happens to be 1. F is mv squared by r. But the beauty of dimensional analysis is that by simple method, we're at least getting the dependence of one variable on the other variables involved. For example, we have got this important information from this dimensional analysis that centripetal force is directly proportional to mass, inversely proportional to radius of the circle, and directly proportional to speed square. This is the beauty, and don't get confused when we equate the exponents. Actually, what we are doing, we are making right hand side same as left hand side quantity wise. That means when I am equating the coefficients, sorry, exponents of m, l, and t, my left hand side is force and I am making right hand side equal to force because force is equal to force, right? Which is the principle of consistency of dimensions. So I hope you got the point. This is all for today. Go through all these problems and don't forget to like and subscribe my channel. You can comment in the comment box. Thank you. God bless you. Assalamu alaikum.